My talk is going to be about the web as a platform for AI innovation. I think, I mean, we're all dedicated to the web. I think that already today, there's amazing things that are happening on the web using ML. I'll talk a little bit about why and what I think some of the awesome stuff that's happening and what we ought to do about it as a group. So first you might ask, why would I want to run my model on the web rather than using a server on the back end? One, privacy. If I don't have to send all of my data up to a server on the back end, I don't worry about inadvertently revealing things. I can also run offline. I don't have to, I don't need a rock solid connection to send all my video stream up to do any of, to do stuff on the back end because I'm able to run it locally. Obviously, latency is also an issue for some cases on the server. We can actually run the inference directly on the device. Obviously, cost. If I have a back end that's doing a whole lot of server stuff, I have a cost on the back end server. Whereas on the other end, if I'm running it on the user's machine, it's free to me on the back end as a web developer. I don't have to worry, like everything else on the web, I don't have to worry about installing an expensive, I don't have to worry about installing a scary app that might do things that I don't like. And of course, because it's the web, it should work everywhere, ideally. So we have a good set of teams that, and you saw yesterday, some WebMN demos, I think, from Intel. A lot of things already running on the web. Segment anything. We saw stable diffusion. We saw chat bots, Whisper to convert text, spoken speech to text, and vice versa. There's a whole lot of other things that our friends from TensorFlow JS have built, and I was going to show demos, a couple of demos of that. One is a toxicity classifier. This is actually, it loaded the model, although it may have been cached. And you can presumably type something like, all right, I'm going to put it down so I can type. All right. Let's see if it classifies it. All right, so it was an insult and it was toxic. So you can get some pretty reasonable results. I wouldn't say the TensorFlow JS one is going to cover all of the things that you might use, but you can see it works and it was pretty fast. It's pretty usable today. Another example, face meshes. We have folks that have built great mesh detection on top, so you can do facials. You can find the face. Let me show a demo of that. I think I have that running. Oh, no, that's the other one. I'll show that one in a second. There's a face mesh, and you can see I can move my head. I don't know, my nose looks a lot bigger in this one than I think it is. It's already big enough, but, and I will say that this specific TensorFlow one is being used in, oh no, maybe I stayed on the page too long. It's being used by L'Oreal to apply makeup to your face, and I was going to show that, but apparently maybe I waited too long. You can see it's downloading the model or something. Maybe I have to click the approve. Probably have an allow button to allow the camera or something. Oh, there it is. So I can change my lipstick. It works, and it's in production, and they're using it to help sell makeup. You might note that I have all of these demos up and running on tabs, and I'm just swapping between them. So that's working reasonably well. Another one, there's hand pose. If you ever wanted to do, you wanted to do sign language interpretation or anything like that, you'd want a model like this. They also have a TensorFlow demo that does 3D pose, which I don't want to dance or anything or do push-ups, but I think that's this demo. But you can see, my hand. It's all live and running. It covers your whole, you know, if you do running or you wanted to see tennis strokes, or there's a whole set of new things that are possible because of these WebMN things that will ideally change the industry, and bring on a whole lot of new amazing things to the web, for everyone, and shortly. And these are available today, all at this point through TensorFlow, but Hugging Face and the Transformers model has another whole set of summarization, and a lot of amazing models have been built, which to me are super exciting for the web and what we can do. Move on to the next. Yeah, they also have full body segmentation. So, I mean, we've had background blur, but we also can do it for full bodies as well. All of these things are using machine learning via JavaScript in the web browser. Of course, behind the scenes, there's WebAssembly and WebGL or WebGPU, but it's kind of amazing that you can do these kinds of amazing things today with, you know, a JavaScript developer who doesn't know anything about ML, but all of these features are available for their use. It's not just demos and things that are up. Adobe Photoshop shipped a version on the web that actually is making use of this ML stuff to do selection of objects and other fancy ML things. So it's, and of course, there's lots of examples from Meet to Zoom that have been using powerful ML for a while, and it's on top of the web using JavaScript, WebAssembly, WebGL, and WebGPU. TensorFlow itself has grown in downloads. Since 2020, it's grown 20x in size. It's now 1.2 million monthly downloads, 300 million cumulative. That's a huge, huge number that we're seeing. So these things are actually being, I mean, they're hot. Everybody is using them. It's been big. In terms of web kind of AI APIs, I mentioned WebAssembly and WebGL. I think most of the demos that I showed you today are currently using some version of WebAssembly and WebGL mixed. And WebGPU opens up a whole new can of worms, in that we have compute shaders and a lot more capacity to do things and do it faster. It's a better API. Of course, in terms of a WebML stack, we have, you're starting with models that I play with. I played with TensorFlow and PyTorch and JAX. You're starting up at a high level models, and maybe you've done a lot of training, maybe using Python when you're doing this. Then they're optimized on top of or compiled for different tool chains. If you don't know about OpenXLA, it's a open source group that is trying to, it's part of, it's XLA and HLO, or it's, yeah, high level optimizations. And it's a group that's trying to come up with another standard for ML. But OpenXL is their compiler. Erie was a compiler that was built that was supposed to be across, kind of like, I think, OpenVINO. Optimum and Zeno are all kind of tool chains that are taking the models and converting them. And then you can run them in a browser using a runtime. Maybe it's TFJS, or it's Onyx, or custom ones. There's plenty of those around. And all of these, execution environments are using APIs like WebAssembly or WebGL or WebGPU. There's a lot of problems and limits with doing this today on the web. One of the things we always talk about, a mix of, boy, the best way to do this thing. The models are so big, we should run some part on CPU, some part on GPU, and some parts on TPU, and they all have different power and speed things, and that gets quite hard. Memory, passing it from one to the other is a very slow operation, and we haven't figured that out. There's bandwidth issues. There's things, even problems with model size. The model size, I think the first one I tried was, maybe I pulled down can't remember which one, but it was a 4 gig model, and you like, oh, let's download it with one of our, maybe it was load HTML, or I can't remember which, but it doesn't fit in JavaScript because we have a 2 gig memory limit. And same in WebAssembly, there's a 4 gig memory limit. And the models are bigger. These big models, I know we're working on all of these things, by the way, but there's a lot of things that get in your way. We're also not supporting the newest hardware that people are building, at least not yet. So there's some problems. I mean, you can't directly use Tensor Core, which a whole lot of people are using to train the models on the back end. So somebody on my team that I work with proposed this as an objective. I think maybe they were thinking for their team, but I think it's an objective for us all. Unlock 80%, at least 80%. I don't want to say it's got to be exactly 80, but like if we got 80, if we unlock 90%, nobody's going to be sad, but unlock 80% of the device's theoretical performance, that's the maximum performance, across 80% of devices on the web, well, imposing a manageable support burden on browser vendors. And I'll talk a little bit about all of that. Obviously, we want it to be performant and efficient and not to have a big gap between using a native app and something on the web. We want it to work for most of the web. We want this to be usable by almost everybody that has a laptop or a desktop or on a mobile device. And manageable support burden on browsers means that we don't want to support 150 different variants of hardware vendors who want to ship their own sort of special purpose hardware. So we need a solution that's actually manageable by by us, by Safari, by Firefox, by everybody in the ecosystem, so that we end up with something that we can actually build and extend and keep using. For us, we are looking at design targets, some obvious workloads like segment everything that you saw yesterday, stable diffusion, Whisper, those kinds of things are workloads that we're looking at. Runtimes like TensorFlow and Onyx, maybe Erie, TVM, these other things, Erie's that open XLA, HLO thing that I mentioned. Systems, we absolutely want it to not just work for our browser, but we also want it to work on our browser on Windows. We want it to work on Apple, iOS, Mac OS. We want it to work, use maybe Core ML on Apple. We want, obviously, for it to work on Windows with DirectML. And we also want it to work on Android and Chrome OS. Obviously, we talked a little bit about hardware. Apple has the Neural Engine, which we hope it will work for. We want it to work on Intel VPUs and TPUs, ideally also Google TPUs. We care about latency, throughput, power. Chrome, we plan to measure and get bench loads of things that we care about. We're going to track latency, throughput, power, that kind of a thing. We're hoping to extend a bunch of the existing APIs to do even better. WebAssembly, we can make wider. We can have half precision conversions. We can do more with floating point, smaller floating point extensions. Similar with WebGPU, you might have already seen we're trying really hard to land a 16-bit floating point. That's already in the works. Integer 8 operations, DP4, BF16. We might look at further extensions to the language. And of course, we will be working with the WebML working group. You heard about WebNN yesterday. We're hoping to positively impact that group and land at something that we can all use and be proud of. Connect, this is about, we talked about memory movements and issues between CPU and GPU. We need to make that work better, so you'll see things, you'll see work that we'll be looking into on better memory control, memory maps, streaming file systems, things along those lines. We would love to optimize the ability to switch between CPU and GPU, or CPU, GPU, and TPU, and make that actually work. Right now, you take a lot of extra copies to do this kind of a thing, even going from JavaScript to WebAssembly and things along those lines. So we're hoping to make that better. You'll see WebGPU readbacks are still pretty slow. WebAssembly, JSPI, these are all things that we're talking about. We want to obviously activate the ecosystem to use these things. We're talking about validating and measuring our uplift. Once we ship it, we're hopefully testing it and seeing that we're having a positive gain. And if not, we'll change course a little bit. And evolving the WebML APIs, we're hoping that we get to a place where everybody, every vendor, Apple, and all of those are on board and that we can move forward. In the end, I personally am super excited by what we can do. I've played with a lot of different demos. I put together things. What we are enabling on the web it feels like a whole revolution of what you can do. And I'm super, myself, incredibly excited and have done a lot of playing myself with the tech, what it can do. I've built models, I've run them on the web, and I think it's a new era of what's possible, and I'm excited about it. I hope you all are, and I hope that you'll join us in bringing this to the web and have it be the place that people do all, that we enable the millions of developers who develop on the web to bring these kind of experiences to their users. And I'm really excited, and I hope we can get your help and support. I know some are already working on it, but I didn't have my speaker notes, so if I messed up anything, that's the reason. That was all I had for the talk. I don't know if we're doing questions or anything.
We can. A little bit long, yeah.
Does anybody want to? I mean, I will probably point to experts if anybody asks me anything too hard. I see in the back.
Victor will run a mic.
Was it?
Thank you for summarizing the opportunity and the challenges in this space so well. I agree with all the problem that you stated in the talk, and it's a problem with great complexity, and it involves many parties in the software stack to help solve this. But I cannot help thinking that a lot of those can be solved by having people working on WebNN topics such as hardware access and be able to keep up with the new technology that comes to the PC is the purpose of the working group working on WebNN. So you touch on one of the data points about direct ML and how do we take advantage of things like Tensor Core and all of that. And direct ML has been supporting features like this for the last many years.
Mm-hmm.
And when we started looking at WebNN, this is one of the canonical example of, yes, would it be great to have the web apps having the same access as the apps running outside of the browser? So yes, there are more than Tensor Core. They are all over the place. And the NPU is coming out next year. So, and that will be a great race. It will be the area. Of course, in this NPU space, Apple has been ahead. They have the ANE since a couple of years ago. But we hope to kind of have this work stream being a challenge to Apple also to help improve the state of the web platform. Thank you.
Cool. I think you'll see that we're going to be way more involved in the WebML working group. Josh is here. If you haven't met Josh, he is definitely. I don't know if you're going to the meetings yourself, and we will have a set of other folks who will be joining and helping in the effort. So you'll see Google put more into this effort than we have in the past. Cool. Any other questions? All right. Happy to be done. Thanks, everyone.